Good afternoon. Wow. Major. Right, good afternoon, welcome. I'm glad you all made it back from lunch in time. I'm very excited to announce our first invited speaker, Joe Wood. So I tried to figure out when we met. It's more than 10 years ago, but that's exactly how far I got. So Joe started out in geographic information science and then moved further into geovisualization, visual analytics, basically working with spatial data, analyzing spatial data, but mostly also visualizing spatial data and communicating insights about spatial data to people. His work, well, I find some of it is actually more art than science, or it's on the boundary between art and science. He has had exhibits. Some of it is just downright beautiful. I've always been incredibly inspired by it, and was so lucky to collaborate on a couple of occasions, leading to some of my more out there papers. I'm hoping all of you are going to be as inspired as I always was by seeing what he's doing. And I'm basically just keep on talking while people are still walking in, so that Joe has your full attention. Right, I think we are reaching a break in the people. So please join me in welcoming Joe Wood.
Thank you, Bettina, and thank you for summarizing the first 15 minutes of my talk, because what I wanted to start with was a confession, and the confession is I am not a computational geometer, I am not a mathematician, I am not even really a computer scientist. My home has been a computer science department for the last 20 years, but really I'm, by background at least, when my computer wakes up, sorry, I'm a geographer. Well, I was a geographer. I started my academic career looking at rocks and plants and rivers and soils, and hopefully relevant to this next hour, also to cartography. And I think cartography provides the bridge between the discipline that I emerged from and the discipline that you are all involved with. And in particular, the early part of my academic career was involved in the depiction and characterization of terrain, of landscapes. And some of you may see the connection already there. The mapping of terrain draws, as Bettina suggested, from some of the traditions of the visual arts, with hand-drawn terrain, but also ties in nicely with some of the issues that some of you are dealing with topology of surfaces. And that was my entry into this world between the geographers and the computer scientists, where I was looking at things like the depiction of terrain, modeling light sources, which ironically you can't see because of the sun light source projecting onto this screen. But I was looking at things like local shaded relief characterization, not by simply characterizing surface normals, as is often done, but by trying to characterize the features themselves that were being depicted, identifying ridges and channels and saddles, and then changing the light characteristics depending on the feature, depending on the scale of the feature. So I was stumbling across, coming from a tradition of cartography and the arts in some ways, stumbling across things like the Morse-Mail networks, where you are doing the same, where you are characterizing the topology of surfaces in order to understand them. And I was needing to do something similar in order to depict those landscapes in a way that was meaningful to those who wish to interpret them. So there are connections, but they come from quite different places in this disciplinary landscape. Geography, where I emerged from, draws some of its traditions from the social sciences, from the arts, and the physical scientists. We're looking at things like atmospheric models, quite strongly physically science-based, but also cartography draws from the visual arts, and the social sciences are quite dominant in the discipline. And then at the other corner, there's you with your computational geometry backgrounds and drawing from traditions of mathematics, the rigor that comes from that, the precision that comes from that, from computer science that gives us the mechanisms to express some of these ideas that you're exploring. And these two landscapes, quite different in some ways, but what attracts me is this unmapped, in many ways, position between the two that links these two disciplinary traditions. Because that's, to me, where there's the exciting blend of rigor and creativity that really excites me as an academic, and I suspect may excite many of you. So this unmapped, uncertain area that draws on these two traditions is where I see visualization fitting. I mean, it's quite clear, it's obvious to you, and it's become obvious to me just this week at least, that visual depiction of the ideas you're expressing is central to the way you communicate those ideas. I think every single talk I have seen this week so far has involved some kind of visual depiction that people refer to when they're conveying the problem they're addressing. And likewise with visualization for us, of course, we use the visual to express ideas and communicate ideas and explore ideas. And that's what I want to talk about in the next 55 minutes, is really how we use some of those traditions of visual communication to foster understanding, to generate knowledge, to explore our reasoning processes. But I do just want to go back again. I was reflecting when I was asked to give this talk on my own history and whether it would be relevant to an audience like this. And I was reflecting on the first bit of independent research I ever did in the mid-1980s as a geographer undergraduate. And I was looking at the topology of stream networks. And I was looking at how the underlying geology might influence the topological structure of those stream networks. And that was in the mid-1980s from a geographic point of view. And then I noted last year at this very conference, we had a talk on the topology of river networks in a braided stream system. So, you know, there are clear connections coming from two directions, but nevertheless we're addressing a common set of problems in many cases. But as I said, what interests me is the midpoint between these two traditions and what we can each learn from the other through the act of visualizing our ideas. And one way in which I think it is interesting to conceive of this is to look at a model that came from visual analytics, from my academic discipline, which considered the space in which visualization can play a role. And they, in this model from Sedlmayr and colleagues a few years ago, they suggested that you can conceive of that space as having two orthogonal axes where we characterize the information we're dealing with on a spectrum from that which is expressible digitally, that we have contained within our computer systems on one end, and then at the other end, ideas that are vague, that are in our heads, that aren't expressed digitally. And that acts on a continuum because we have some ideas that we can have proxies in digital form, but really don't quite capture the nuance of the information that we're trying to convey. So we've got this spectrum along that axis, and then orthogonal to that, we have the clarity of the tasks with which we're using that information to try and address. Sometimes we have very crisply defined tasks with a very clear, precise description of what it is we're trying to do. Sometimes we might want to explore, we're not quite sure what we want to achieve. The task itself is perhaps less well formed in our minds, or it is simply not expressible in crisp terms. And those two continua, I think, give an interesting space to explore. And most of what I've seen, and I suspect most of what many of you do, sits in the top right-hand corner there, where you have a very well-specified description of the input data you're dealing with, and you have a very well-defined description of the task you're trying to address. And that might involve making many assumptions and many constraints in order to get that crispness. But that's the space you're exploring. I'm interested in a lot of the stuff that happens in the middle, where we don't necessarily have complete description of what we're trying to achieve or capture completely through the data that we're using what it is that we're dealing with. Nevertheless, there are some elements of that. And the visual is important in that process because the visual itself is also poorly defined. It is subjective in many ways. We each interpret the same image in different ways. It's not a linear process, it's a complex process that happens in parallel with our visual system, and I'll give some examples later on of that. But that maps well onto tasks that themselves are also not well expressed and are subject to ambiguity. And yet, within the visual analytic community, what we strive to is to move towards that top right-hand corner. Through the act of exploration through the visual, we try to clarify the crispness of the task we're addressing, and often that allows us to clarify what data we need in order to address those tasks. However, much of the work that I've done that sits in this space, I reflected on in a paper a few years ago where we looked at how we moved within that space over time with various projects, particularly in this example, projects that are related to transport, movement of people around London on bicycles in this particular case. And we noticed that we were moving around in that space in quite a fluid way, not necessarily always going towards the well-defined crisp corner. Sometimes we were moving back again as we uncovered new questions that made things that we thought previously were simple turned out to be more complex and more poorly defined in some cases. So I think it's worth reflecting on the fact that we might be working in this rather fluid space and we need to be able to navigate around. And visualization, I think, provides an opportunity to do that. So as a sort of visual summary, in the top right-hand corner, there's you with your crisply defined problems expressed in crisp geometric terms. And yet we've got this space that gets increasingly messy as you move down towards the other corner. And I think it's interesting to reflect on the role that visual plays in exploring that space. So let me give you an example. It will be familiar to at least the Eindhoven crew in the room today. Let's suppose that we have some area, some region that's subdivided into subregions. Here we've got 12 provinces of the Netherlands. And we want to map that. Now, here's a map of that in a conventional form, but we might want to map it in a different way. We might want to, for example, have each of those provinces represented as a rectangle. Now, from a visualization point of view, that's handy for us because that allows us to embed within those rectangles other graphics that might represent some characteristic of those regions, like bar charts or scatter plots. And when we're dealing with nice rectangular regions, it's easier to embed other forms of graphical summary. Now, the process of mapping from the left to the right there is a classic, nice computational geometry problem. You can set up your constraints, you can explore ways in which you do that. And of course, what makes it a nice problem is that we have to make sacrifices when we transform from one set of units to the other. We might have to sacrifice topology, where we have previously adjacent regions may no longer be adjacent under these constraints. We might lose direction or distance. Now, what makes this an interesting problem to me is the fact that there's a trade-off between those desired characteristics. And we might complicate the situation further by saying, well, let's suppose that we don't just simply want to transform 12 provinces into a grid of 12 cells, but we add extra cells, gaps, blanks, so that gives us a greater degree of freedom. So if we have many, many cells, then that gives us more freedom to place the cells that represent the 12 regions within that space. But of course, we sacrifice topological connectivity when we do that, but we gain in some of those other characteristics like direction and distance. And what that leaves us with is a much richer space of optimization goals, if you like. Unfortunately, you're not going to be able to see the enumeration of them here, but what we have here is for each of these possibilities where we're increasing the number of gaps that we have available to us as we reproject the space. We then measure the characteristics such as whether the assigned spaces are aligned vertically, which allows us to make some comparisons of magnitude, or whether we're preserving topology, or whether we're preserving direction, and there are about 20 of these constraints that we can, optimization goals that we can consider. And that typifies to me what makes this space an interesting one, that we've got a much more complex and nuanced set of goals than we might originally have assumed, and that the visual exploration of these alternatives is an ideal place in which to explore the merits of those different goals. And I would argue that visualization, therefore, plays a central role in assessing the value of the computational geometry required to project from one space to another. So, having said something about where I've come from and why, and motivate perhaps why I find this space interesting, I want to reflect a little bit on how we've used visual storytelling, not just visualization, but the act of telling a story through visual means to support the reasoning that we sometimes wish to either convey to others or even to explore internally ourselves. And I've seen many, many examples of this, as I said, in every single presentation I think I've seen this week, and of course everything that you do typically is that you are supporting the reasoning that you're wishing to explore through visual means. And of course this is not new. We've been doing this for a long time. The first ever printed edition of Euclid's Elements did exactly what I've seen in many of these talks this week, which is to support a narrative with simplified abstractions of the geometric concepts that were being explored. And of course, it's not even, we can go back further than that. We can go back 3,000 years to see the act of the visual exploration, the visual support of a reasoning process. And even you could regard this as a proof through visual means alone of Pythagoras' theorem. Yeah. So 3,000 years we've been doing this for. Slightly more recently, but not that much more, I like this example from an engineering manual in 236 AD that was demonstrating how you could triangulate the height of a distant object where you couldn't get to its base if you triangulated that position from two locations of a known distance apart with a pole of a known height. A fairly straightforward to us now form of triangulation, but I like the way in which this was conveyed visually because it's an example of the visual supporting the reasoning that was behind the process, but also I like the blend of the abstraction of the two right-angled triangles and the more figurative representation of the process of triangulating the height of this island. And those aren't just ornamentations, they help to convey the meaning of what's going on here. The fact that this is about an island that is inaccessible and there's a depiction of the choppy waters between the survey point and the point that's being measured illustrates the fact that this is about a remote process of using reasoning to identify a characteristic of something you can't get to physically. And I even like the touch of the birds on here because we've got this sense of a sort of figurative space towards the left and an abstract space with the triangles, but the birds are there just to remind us that this is an applied process. This is a manual for engineers for achieving real tasks. So there's a story behind the image which we may not register consciously, but it helps to support the goal of the visual here in persuading people that there is a process by which they can survey heights of remote locations. Jumping forward more recently, of course, we can still use the visual form to explore reasoning. And I should say I started preparing this talk before I'd seen the program for this week, and before I noted that on Thursday, the author of Wednesday, oh, I'm sorry, Wednesday. I haven't got time to edit the picture now, but I encourage you to go along on Wednesday at, hopefully it is still 3:30, to hear the author of these wonderful algorithms without words, because they illustrate very nicely that the kinds of concepts that we deal with don't necessarily have to rely on words to convey them. We have pictorial conventions that help support that. And these aren't just simple ideas like the triangulation of a hilltop. They can be quite interesting and more complex algorithms that can be illustrated in this way. And because you're going to hear much more about this on Wednesday, I'm not going to say much more other than it is an interesting challenge to take a concept and try and convey it to someone without using words. The discipline of doing that helps you refine and abstract the concept in a way that I think is quite a healthy one, and I'd encourage you, if you're not doing it already, to do so. But I also want to say that this process of using the visual to support reasoning doesn't have to apply just to those activities in the top right-hand corner of that space I talked about. We can convey complex ideas that are more ambiguous as well. And I note that this week, well, earlier this month, Megan Parker graduated with an MA in Canada with her thesis that was entirely in comic book form. And it's a serious thesis talking about complex ideas with the depth that you'd expect from a master's thesis, conveyed through visual means. Now, there is text in there as well, but it's interesting to reflect on what the visual adds to the process. And this is not just about it being a sort of change for change's sake. It's about thinking about what the visual uniquely offers that we can't express through other means. Now, in some ways, what it does, the comic book form at least, gives you a narrative. It gives you a way of sequencing, which may be somewhat linear if you're reading from left to right, top to bottom, but it does allow you to move in non-linear ways as well, in a way that the written word tends not to. It can also convey ideas that are inexpressible with words because they are vague, they're perhaps ambiguously formed, and the words don't capture that ambiguity or that nuance. And the comic form, the visual form, may be one way in which we can map onto that inexpressibility and the ambiguity of interpretation that's necessary to deal with them. So it's interesting to reflect on attempts to do this and what that tells us about what the visual has to offer. I want to give you one other example from my sort of tradition, and it's one that you'll be familiar with. If not this map, you'll certainly be familiar with the consequences of this map. Mercator's 1569 projection of the world, a sphere onto a plane, is a beautiful document of visual cartographic storytelling with plenty of embellishments and detail that are just interesting to pore over. But also they tell other stories. They tell stories of where in the world 16th century Dutch navigators had explored and mapped. The level of detail varies across the map in a way that tells us a story of what had been discovered and what was important. But of course, there's a very specific analytic function that this form of projection also achieved at the same time as telling these more sort of evocative stories. And that was a projection such that a line of constant bearing was represented by a straight line in this projection. And that performed an analytic task, or that allowed analytic tasks to be performed that couldn't be performed previously. It allowed people on board ship to navigate with straight lines and relate those to the bearing of the ship across uncharted oceans. So we've got this combination of the story and the analytic function all within the same document. And I like the richness of that juxtaposition. And I like the examples that say, here be dragons, here are some of these uncharted places, with all the trepidation and fear that might have engendered in 16th century explorers, juxtaposed with this precision and analytical function of these ROM lines across the projection. And the history of visualization is littered with these examples of these rich documents, and this will be familiar to many of you, I'm sure. Just in case there's anyone in the room who isn't familiar with this, very briefly, this is a map produced by Charles Minard in 1869 of the disastrous Napoleonic march to Moscow and retreat of the soldiers. The width of the lines, the brown lines and the black lines, reflect the number of troops involved over time and space. So we have a map that starts in the bottom left-hand corner, roughly where Poland is now, with all the troops in brown there, gradually getting thinner as troops die as they work their way through the Russian winter to Moscow over time. And then the ignominious retreat of the troops that continue to dwindle in numbers. And then along the bottom we've got lines of temperature, which played obviously a significant role in that campaign. And we have other richness. We have contextual richness there. We have the rivers that had to be crossed in these atrocious conditions that result in the losses of many, many lives. And this tells a rich spatio-temporal story through visual form. And it's an emotional story as well as a factual one. That the fact that if you compare the width of the line here where the campaign started with the width of the line here where it ended, and realize that that is the proportion of people who died in the campaign, it conveys a message with emotion as well as with factual detail. I have one more somewhat cliched example, but I think it's worth mentioning here, just about visible in this light. The simple act in the 1980s of iterating a complex number with the equation x equals x plus c, and then counting or measuring the locations of c such that the iteration shot off to infinity, and measuring the speed of that trajectory, produced these fractal maps that gained a much wider public appeal, much wider than the mathematicians who conceived of them. And I think it illustrates the fact that there is another power to the visual representation that in this case illustrated the hidden complexities of that boundary between order and chaos that resonated with an audience of non-mathematicians as well as those like me in the 1980s who were somewhat seduced by the visual appeal of these mathematical processes. But I want to kind of ground things a little bit, though, and move away from some of the examples and just think about, in more detail, what it is about the visual that we are good at processing and what it is about the visual that we're not so good at processing. Because in doing so, I think it helps us guide the design of when the visual is helpful to us and when it is not. So, yes, even with the sun out here, you can see the lines on the screen here. I just want you to look at those and to see whether, imagine that each of those lines represents a quantity of some kind, and to think about what that tells you about that collection of quantities when you process that image visually. I'll just let that stay on the screen for a little while, and then ask a rhetorical question, but do see whether you can answer it in your own mind. Imagine this is on a piece of paper in front of you, so we've all got a common scale, and if I asked you what was the total line length that you can see on the screen there, I want you to go through that mental process of trying to work out what that line length would be on the scale, imagining this was a piece of paper in front of you. 50 units, yes, I think it's about 50 units as well. Now, there's going to be plenty of different views as to what that length will be. We've got some of the finest minds in the world here who are capable of constructing abstractions in their head, so should be well attuned to this kind of problem. But it's a hard problem, and I would suggest that even in a room like this, the variance in our estimates of that total line length could easily be a factor of 10. The shortest distance that someone has guessed is maybe a tenth of the longest distance. We're very poor at that kind of estimating task. If I ask this question, I would hazard that the variance in the answer that we get is probably closer to 10% rather than a factor of 10. We're all going to be pretty much in agreement about what that length should be. Now, it's interesting to ask ourselves, why is this question so much easier to answer than the other question? Because if we were to calculate the average length in the same way that we might do arithmetically, in other words, summing the lengths and dividing by the number of lines, then the previous question should be easy, because, of course, we have to sum the lengths for that as well. So something else is going on here. Our visual system is not doing what we might do arithmetically. And what we're doing, and what the visual system is doing, is creating an archetype. And this is what we're very good at doing. We're very good at processing a visual field and abstracting an archetype from the complexity of the visual field and saying, well, this is typically what I'm seeing. And we can do that with the lines. Our brains do that. And they do that in parallel. We don't have to scan the lines individually. We do that in an instant. We can say, well, here's a typical line. And therefore, a question like, well, what is a typical line length, is easier to answer because our brain, and to use Daniel Kahneman's term, our system one thinking is very good at that. We've evolved to do that kind of task. So tasks where we need to identify archetypes, or to nail it down here, the average length of a line, are much easier than some of these other ones that involve some mental reconstruction of an image. But how can we as visual designers make that task easier, or both of those tasks easier? Well, we could choose to keep those lines in their same location, the midpoints in the same location, and just reorient them so they all have a common orientation. Maybe that helps, maybe it doesn't. One of the problems we get is that we start having these Gestalt principles now applying, where we start not seeing those lines as individual elements, but we start seeing them as collected entities, and we start merging these lines into larger units. And that if we're dealing with tasks that need to disaggregate that, that's now harder than it was before. So thinking about the nature of the task in relation to the depiction is quite important here. If I take those lines, though, and I reposition them so they have a common baseline, then understanding their characteristics becomes easier still, and it becomes instant. And we can see there's one line that was longer than all the others. Out of interest, how many people had spotted when you first saw that distribution that one line was longer than all the others? Well done. 1, 2, 3, 4, 5, 7 of you, 8 maybe. Most of us didn't. I didn't. The simple act of reorienting those lines, giving them a common baseline, reveals new structure in the distribution that wasn't there before. The lines are the same. The magnitude, the representation of magnitude is the same, but just the repositioning of them reveals a new structure. And if we do the same, if we just reorder them, we can say something about the distribution perhaps more clearly, as well as the fact that there's that outlier there. And these are the kinds of design decisions that visualization people do all the time. We think about what kind of task are we trying to do here, what kind of, how many degrees of freedom do we have as a visual designer to think about changing the visual characteristics to reflect the task at hand. But if we go back to that question, where's the outlier? For the 7 of you who already spotted it, you know where it is, but the rest of you have got a chance now to find where's that line that was longer than all the rest. Now, the fact that you now know there is one may make this task a bit easier. And I can see by some nods of heads that people have got it. But every one of you, apart from maybe the 7 who already knew where it was, were probably going through a scanning task there. You were looking serially through those lines until you, oh, there it is, till you found one. And that, again, is a system 2 type of processing, as Kahneman will talk about, which is something that is an active act of having to invest in the cognitive process of looking for a line. If I'd said, where's that longest line now, you would all have found it, and that would have been a much easier pre-attentive process, because we've evolved again to spot contrasts in hue, and even with the sun doing its best to make these images fade, we're able to spot that without doing that scanning task. It happens in parallel. And again, visual designers will exploit this to say, well, if this is really important to highlight this, I will use a hue contrast in order to make that a low-effort, instant response. Now, there are many other examples of how studies into perception can be used to inform design, but what I want to emphasize here in the context of storytelling is that the rate at which we might have to process the visual in order to observe these things varies depending on how easy the task is. And that gives us, in effect, a form of sequencing that allows us to say this thing is the first thing we're going to see, and then this thing is going to emerge, and then this thing with a bit more thought might emerge later. And that gives us something to work with when we're constructing a narrative, a story that says, first understand this, then understand that, then understand something else. And these sorts of decisions are important when things get more complex, because you can't rely on your ability to scan. If I was to tell you that one of these 64 distributions of lines is different to all the other distributions, and maybe the 7 of you who got the first one would get this as well, but I don't know if anyone spotted it yet, but one of those collections of 64 is different to the others. It's hard. You'll be scanning, and you may find it, but it's not easy. If I do that reorientation exercise again, oh dear, it is quite washed out on the screen. But you may have spotted that one of them is slightly different. If I exaggerate the vertical scale, that may become more obvious. I should add that because we're good at identifying structure in visual pattern, that works to our advantage. It can also work to our disadvantage. I suspect, not from where I'm sitting, but where you're sitting, it may look as though you've got a slightly sloping baseline to all of these charts. And that's because what we're doing is we're noting the sloping baseline at the top of each of these collections of lines, and we're imposing an orthogonal structure on them which effectively rotates each of those charts in our mind's eye. And so it looks as though the baselines themselves are sloping slightly. And that's something we have to be aware of, that our visual system can also distract us and introduce artifacts as well as insightful patterns that exist in our depictions. Because the screen isn't as clear as I'd hoped, I'm not going to dwell on this for too long, but just to give you an example of how I, as a visual designer, might exploit some of these issues I've been talking about. This is a map of flows, of connections. It's a region of northwest England, subdivided into regular grid, and what you're seeing is that within each of those regular grid squares is a mini-map of the entire region. So we've got the entire region repeated however many times, 17 by 17 times here. And within each of those squares, we've got some color coding going from orange to red, which reflects the intervisible regions. So if I take one corner, and everything in this corner that it can see that is visible from that location is depicted in red within the square itself. So it's an intervisibility map. So rather than showing this as a graph, a sort of node link type representation, we're showing it as a geographically embedded matrix, where we're effectively origins and destinations are being shown with color here. Now, once you've done that, once you've understood what it means, or once the analyst has understood what that means, we can then start using our ability to extract patterns there, to see lineations, to see subregions, to understand the structure, the multi-scale structure of the intervisibility of the surface. Now, I know there'll be research within this field that looks at those kinds of problems, probably not using the visual form to express it in quite those ways. But there is, nevertheless, I think, a connection between what we're trying to achieve there. So I've already hinted that we can exploit our ability to process the visual to construct narrative by looking at the order in which and the ease with which we can generate understanding. Let's just briefly consider some of the other models of storytelling that have been used, not necessarily from visualization, but just as a process, to see whether we can learn anything about how we apply that to the visualization context. And of course, the idea of narrative, of sequencing a story, is not new, and partitioning a story into segments, into chapters, into a beginning, a middle, and end is not new. We can go back slightly more recently. If we look at dramatic structure, and we can look at the 5-act play that identifies these 5 elements, as Freytag did in the 19th century, of exposition, rising action to a climax, to falling action to the denouement. And in the context, perhaps, of the kind of ways in which we might communicate what we do, this is really about explaining the context of something first, then explaining the reasoning necessary to derive new knowledge, take that new knowledge and apply it in some way, and then reflect on how the application of that new knowledge might be taken into the future. And in a way, this summarizes almost all the talks I've seen this week as well, where people start with a problem, they contextualize it, they then go through the reasoning that led to an understanding of that problem and a solution to that problem, and the implications of that solution for future work. So we're quite used to structuring stories in this way. Within the visualization context, there are other models. This one was one of several articulated about 8 years ago, where they were looking at visual interaction in the storytelling process. So when you build systems that allow the user to interact with the data in some way, there are different ways in which that interaction can take place within the process of a narrative. And this martini glass model is the idea that you introduce someone to an interactive system first by not allowing them to interact at all. That's the stem of the martini glass. And then you gradually open up the opportunity to interact, to explore, as people learn more about the system that you've presented to them, until they're left with a free-form exploration environment once they've gained the knowledge, once they've been directed along the stem of that martini glass, as it were, to be in a position to navigate more effectively. But there are other models in which we can think about how that interaction takes place. The idea of taking the narrative structure, beginning, middle, and end, and then within those units, allowing some kind of interaction. The interactive slideshow effectively is that example. Or in a less linear sense, we might have the ability to drill down on a region of interest and interact with that at will, so that we're not constrained by a linear narrative, but we can explore according to our own needs. And then there are other models that are more sophisticated, that don't have anything to do with visualization directly, but I think have relevance. They can be applied. A well-known story that some of you will be familiar with, we see repeated again and again and again in mythical storytelling and more recent storytelling, the idea of the hero's journey. That a hero who starts in a familiar, ordinary world is somehow transformed into an extraordinary world where they have to adapt to changing environments, changing situation. They learn from that process and then bring back that knowledge back to the ordinary world again. It's a metaphor for much of what we do when we are exploring new ideas. And it may be familiar to you not simply because it occurs in story after story, but because that's exactly what George Lucas used, that model, in the construction of when he wrote Star Wars. He explicitly injected every single element of that 12-point model into the story. And you can map them very precisely, the plot of Star Wars into this model. So these models, I'm interested in exploring how can we take theory of storytelling from other domains that resonate with us for other reasons and think about how they might apply to our visual designs and the use of the visual to communicate the ideas we're interested in. One model that I see again and again, and I see examples of this this week as well, is what Nancy Duarte calls the contour of communication, where she says a compelling story contrasts what the world is like with what it could be like, and it moves backwards and forwards between these two states, possibly getting closer and closer as the contribution that you're wishing to describe tells us how we can go from what is to what could be. And they're typically bracketed by a kind of call to action. This is what I want to be able to do, or want you to be able to do. So I call to adventure, and then leave us with a call to action. This is what can happen in the future as a consequence of what I've told you. And once you're aware that these structures exist, it's interesting to think about how people have used them in their own storytelling to convey things more effectively. But this may seem a little bit abstract to many of you, or unrelated to what you're doing, so let me try and tie this down more closely to the process of the visual. And this work that I want to just give you a couple of examples of came out of a Darkstall workshop I was involved with a couple of years ago, where a number of visualization designers, academics, and computer scientists were mixed together with some journalists who are interested in data-driven storytelling. And we looked at how the visual can be used to support that process. And what a subgroup of us did is that we came up with these things called Napa cards. And there's a URL, napacards.net, if you want to explore this yourselves, which took examples of storytelling narrative patterns that we see in other forms of story, and we looked at how they might apply in a visual context, in a visual design context. And I want to give you a couple of examples. Just about clear enough on the screen, I hope. Here's a nice example of where we are using visual hierarchy to construct a narrative. Now, a map, unlike a piece of text or a sequence of words being spoken in a talk like this, is not necessarily linear in that you're not forced to start in one end and work your way through in a sequence. You can look at it however you like. But the visual designer here from the New York Times used visual hierarchy to try and encourage a particular sequence of interaction with this map. The first thing that I suspect many of you will have seen noted from that, even on this faded display, are the red arrows here. They're dominant, and we might look at those arrows and we might see this is representing flows of some kind. That might lead us to ask, well, what flows of what? And we might be drawn to the title at the top to maybe contextualize it. We might then be drawn to looking at some of those places of convergence of those arrows to think, well, what's going on there? And then we have text to support that to maybe tell us a little bit more about what's happening in California or in New York State. And then you might notice, even on the faded display, that behind all those arrows are these green patches showing something else, which in this case show the state gun control laws in various states. And then we start piecing together the connections of flow of illegal use of guns in crime and the variation in the status of or gun control across the states. And we begin to picture this story. And that sequence of events is determined by the visual design, by what our eyes drawn to first, what we're able to interpret most quickly, most instantly, and then secondarily looking at some of the contextual information that itself can be visual. And a good visual designer will be able to influence that passageway through what apparently is a non-linear story to make it navigatable. Another technique common in storytelling, particularly in science fiction, is the idea of defamiliarization, that you take something you're familiar with and you put it in an unfamiliar setting. And you change some of the rules, but you leave enough of the rules in common to be able to relate to the situation. So simply the act of turning a map apparently upside down, but still having the labels so that we're reading it this way around, it alters our perspective on a problem. And that can be, the act of surprise there and the act of reframing a context can be a powerful one. And part of that reframing is a good example here I like, because I think it relates to one of the tasks that you're often addressing, and that's to do with the efficiency with which we might represent something. And here we're going to break a rule. We're going to make something less efficient than it need be. So this is a graphic that appeared in Reuters a few years ago, showing the proportion of women in senior positions in US manufacturing industry. And the red graph on the left, chart on the left, shows an increase in the number of women involved in these senior positions from almost 0 to 3.5%. You can't see the axes on the screen, but that's 3.5% of senior positions, CEOs for the top 500 companies in the US were held by women then. And the context of this was to say, well, women are getting through, they're finally becoming CEOs of these companies. And this incorporates some of the good practice in visualization design, such that if you bank a line to 45 degrees, that gives you the most visual discriminating power when you want to look at variation across that line. However, it completely fails in some other respects, in that does it really convey the magnitude that's being shown here? 3.5% of women, of CEO posts in the US were held by women. And so if you make an inefficient representation in terms of visual discrimination, where we scale things not from 0 to 3.5% vertically, but 0 to 100%, the same data then conveys a more powerful message. That's what 3.5% looks like. It's tiny. Now, that's less efficient in terms of its visual encoding, but it's more efficient in terms of conveying the message of the chart designer. And I think it's useful to step back to think, well, what is it that we're actually aiming to do when we create our algorithms or our visual designs? Okay, so in the final 15 minutes, I want to move away from examples there and think about how we can apply some of those ideas I've talked about in the context of something I'm calling literate visualization. And my second confession today, as well as not being a mathematician or even computer scientist, is that I have a quite personal relationship with my computer, a private one, which is not uncommon. And when I'm designing some visualization, when I'm coding, I have a private relationship with the computer that allows me to tell the computer what I want it to do, and it will tell me how well I've done it, either by expressing that through some visual design that I've told it to draw, or by telling me through debugging information or whatever that I've not got things right. And this is a common pattern that is so common we don't often characterize it, that we are interacting with our computers on this, if you like, forming a private dialogue with our computers when we're doing this. And even when we involve other people, often that's a secondary form of communication. We seek advice from others, or we share ideas with others, but then we get back to the primary private conversation between ourselves and the computers that we program. Now, maybe for some of you who are more theoretical and not involved with actually coding stuff up, that doesn't apply, I don't know. But it certainly applies to many of us who are using computers to achieve the kinds of things we've been talking about. And what literate visualization is all about is trying to change the nature of that dialogue so that instead of being between the person and the computer, it's between people. And the computer is simply mediating that conversation. And it emerges from Donald Knuth's idea that I'm sure you're all familiar with of literate programming that emerged in the 1980s, where he recognized the fact that most of the work he was doing when he was coding algorithms wasn't really to tell the computer what to do, it was to tell other people what to do, or how he was doing things. It was a communication between people. And he recognized this by saying, if I'm constructing a narrative that I want to use to describe what I'm doing to somebody else, that narrative should be what I choose to be most effective as a communicator, and not what the programming language I happen to be using says I have to do. First declare your variables, then do this, then do that. And he was working with Pascal at the time, which constrained to some extent the sequence with which he could express many of the algorithms. So he came up with this system that really allowed you to decouple the sequencing that computer programming language required from the narrative sequencing that forms effective communication. And the legacy of that is really the notebook environments that many people, I don't know how many computational automators use these, but things like Jupyter Notebook or Observable. How many people use Jupyter or Observable? So a fairly small proportion, but a few people have. Very briefly, just enough time, I think, show you. Observable, well worth looking. beta.observablehq.org. A set of these interactive notebooks that allow you to explore algorithmic process through visual means. I'm going to very briefly, there's a whole catalogue of these, and you can submit them, just show you one, because I've seen several disk covering talks in the last couple of days, and here's an example of both incorporating animation of the problem, but also interaction that allows you to explore the effect of the particular algorithm that's encoded here. And the algorithm itself is both explained and also represented in code somewhere. Oh, lost it off the bottom. Here we go. That you can also delve into and change. So you can actually use this very environment not simply to communicate to others, but to explore the algorithmic process itself. And I think it's quite a powerful means by which we can explore ideas. And there are plenty of computational geometry relevant examples on the site. But when it comes to visual design, this is closer to what I often do, and many of us do, which is that we have these vaguely defined problems that require exploration. We don't quite know what we're aiming for when we first start. And this led me to develop what I'm calling LitViz, an environment, a notebook-like environment, a bit like Observable, that really supports this idea of exploratory communication with other people of new ideas with visual support. The URL's there if anyone's interested in it, but really it's about the principle I'd like to share in the final 10 minutes. It's a notebook environment that mixes rendered visual output on the right here with code on the left, but also textual narrative on the left as well. And just like Donald Knuth's literate programming, the sequencing is not determined by any requirements of the code. It's determined entirely by you as the author of the narrative. So we make the narrative process the primary one here. There are several elements. There are code that is linted in live. You get debugging information as you code. It's reactive, so you change the code. The graphics change instantly in correspondence to that change. We've got narrative using Markdown, for those who are familiar with that, fairly straightforward textual language for formatting text, and that can be, the styling of that text can be controlled as well. And we have something called narrative schemas, which I'll mention in a second, that allow us to inject structure into our narrative. And while it's not a property directly of the software, there's also an encouragement to think aloud, and this is something I think is quite important. We often hear of other people's work in conferences like this where they've gone through the process of exploring ideas and going down dead ends and backing off from failures, and you hear the success stories, and you hear a polished narrative of what went well at the end. But actually the act of thinking aloud of that process of articulating while it's being made, I think is a useful one, and it's supported by LitViz. The screen is not good enough to show you the details of this, but broadly speaking, we've got this environment that allows that thinking aloud process through visual and textual means to happen live. And it encourages this experimental form of developing thought. And not just experimenting, but capturing that experimental process. So in the context of visual design, for example, if I'm interested in, as I was here, in exploring inequality, household inequality in the UK, I might look at the income of the richest 5% of households in the UK and the income of the poorest 5%. And I might want to see whether they've changed over time. So on the left-hand side, we've got a number of very simple line charts that show that. The red line shows the blue line shows the income of the richest 5% over time, over about 50 years from left to right. And the red line shows the same for the poorest. But they're on different vertical scales. If we combine them on the scale, we get where the mouse is here. We get to see the comparison. Now, the details aren't important other than this is just one way of exploring that phenomenon. We might choose a completely different way where instead we have a scatter plot of the income of the poorest 5% against the income of the richest 5%, and then we join those dots with a line over in temporal sequence. So we're reprojecting the same information in a different way. And they're two alternative visual projections of the same data, and I might not know at the outset which is going to be more effective for the task at hand. Now, rather than do both and then decide on the winner and then forget about the loser, as it were, the LitVis environment, and something I think is useful to do, is to capture both of those design processes. And you can think of it as a tree, as you're good at thinking about trees and graphs, of alternative narratives. And then I can choose at a later date which one of those narratives I choose to adopt. And in a simple case, it might be a very simple tree structure like this, but we can build more complex, non-linear narratives in this way that capture not just the path of success, the one that at the bottom is finally presented at the conference, but all those other dead ends that led to the ultimate choice of the successful pathway. And I would argue that capturing the entirety of that process has value. Sharing failure is useful, as useful, sometimes more useful than sharing success. And it forms a critical part of storytelling, that many stories involve failures and apparent sort of terminal failures that are then rescued, and our hero makes it back to the end of the narrative. So the final very quick example that we've injected into this process with LitVis is to think about how do we support the structuring of narrative if you want to convey these complex stories. And this came from an observation, or was supported by an observation from work earlier this year, that analysed these notebooks that I mentioned, 1 million of them, on using the Jupyter notebook that's commonly used by data scientists. And they noted that even though these notebooks provide this opportunity to provide textual narrative, embed graphics in them, embed interaction, a quarter of them didn't do that at all. They were just code repositories. They weren't being used in any different way to a conventional coding environment. And their observation and my observation is that one of the reasons for this is that we need guidelines to help us construct these narratives. We're not used to doing so. We need support. And narrative schemas allow us to do that. They allow us to inject rules into our documents that say, if you're going to follow this form of narrative of storytelling, your story should have these characteristics. And they may be, they're characterized by having labels that we can inject into our documents, rules that say how those labels relate to one another, and styling to show how they may be shown visually. And that allows us, for example, to construct dialogues, explicit dialogues in our narratives, that are conversations between two voices, that says that in your construction of your narrative, if you have voice A explaining something, that must then be followed by voice B, and then followed by voice A. And that allows us, for example, to construct a Socratic questioning schema that has a series of naive questions. Why have you done it this way? Why does this work? To which you answer your own questions by saying, well, I've done it this way for this reason. And it's a form of encouraging critical thinking. Now, they're quite simple injections, but they do make that process easier. And the system allows you to inject these rules in the same way as you might have unit tests in a programming environment that simply just allows you to say whether your document has passed or failed a test according to the rules that you've defined. Okay, because the screen is not that clear, I'm not going to go in any detail through any of the examples, but it does allow us to construct... Sorry? I've got 58 minutes on my timer. Have I... That... Okay, I'm sorry. I make it 1 minute past 3 at the moment. I will finish then with some challenges. I think the big challenge is that space in between the uncertain, poorly specified problems and the clarity and crispness in the corner that maybe you've been dealt with. I haven't got time to go through some familiar examples here, but we've been exploring that space in a way that I think leads to some interesting visual designs. I also think we in the visualization community have got a lot to learn from what you're doing. I'm impressed with the clarity of reasoning being shown in the talks this week, and the way in which you're able to build on prior reasoning and move the discipline forward. And I think that's something we're struggling with in the visualization community, where we have far less crisply defined problems and solutions to them. And I also think when it comes to narrative construction, some of the work that's going on in transitions between states I think has particular appeal to how we might inject those into narrative constructions. And finally, I think I would encourage us all to think about documenting our failures as well as our successes, because I think we have a lot to learn from those. And I will leave it there. Thank you. If I can briefly answer that, yes, so a code can tell its own story indeed, and that was one of the criticisms of Knuth's literate programming, that it was unnecessary. Good code can tell a story, and good code can do that. Bad code doesn't do it so well. But I would also argue that the failures that I talked about are often not captured in good code because they're rejected and you never see them again. So I think there are things, and particularly from a design perspective, that are not captured through code alone. And therefore, I think there is more to it than just simply encoding our thought processes in a simple piece of code.